Hello there and welcome to A2 Maths from June 2018, paper 2, and here we're looking at question 10, an integration question. So a spherical mint of radius 5mm is placed in the mouth and sucked. 4 minutes later the radius of the mint is 3mm. In a simple model, the rate of decrease of the radius of the mint is inversely proportional to the square of the radius. Using this model and all the information given, find an equation linking the radius of the mint and the time. You should define the variables you use. So we'll define this as r and time as t. So let's go back to the question. In a simple model, the rate of decrease of the radius of the mint is inversely proportional to the square of the radius. Okay, so we need to form a differential equation out of this. The rate of decrease of the radius. Now, whenever it says the word rate, we have dt on the bottom. What's the rate of? It's the rate of decrease of the radius. So it's dr by dt equals, it's decreasing, so it needs a negative at the front there. Inversely proportional to the square of the radius. So it's going to be k over r squared. K is the proportion, r squared means that it's inversely proportional to the square. Okay, so there we are. This is our differential equation. We now need to solve this differential equation by moving the variables onto the correct side. So we'll times by r squared onto the left, and we'll times by dt onto the right. So here's our here's our rearranged differential equation, and now we can integrate both sides. So integral of r squared dr, that's going to be 1/3 r cubed, and on the right hand side it's going to become minus kt plus c. Okay, so now what we need to do is we need to work out what k is and what c is. So we should have some variables to put in. We know that the radius starts at 5mm, so we know that when t is 0, r is 5. And we also know that 4 minutes later, t is 4, then the radius is 3. So plugging these two in, we can get two simultaneous equations for c and k. So plugging in the first one, this one's the first one, so when r is 5, so that's going to give it 125 over 3 equals minus, but t is 0, so that's just c is, well, c. And then plugging in the second one, that's this one here, when t equals 4, r equals 3, so r cubed is 27 divided by 3 is 9, equals minus k times by 4, plus c, we know c is 125 over 3, so move up to here, that's going to give us 4k equals 125 over 3, take away the 9, so we've just rearranged this into this, and then divide by 4, so this is going to give us minus 49 over 6. Okay, so it's a bit of a weird number, but therefore that is the answer. So therefore, we're going to have 1/3 r cubed equals minus 49 over 6 t plus 125 over 3. So there we are. This is the formula that links the radius and time. So times in minutes, and r is the radius in millimeters. Alright, so there we are. That's part A complete then. Moving on to part B, let's just write down our answer from part A. Minus 1/3 r cubed equals minus 49 over 6t plus 125 over 3. Okay, part B, hence find the total time taken for the mint to completely dissolve. Okay, so what we want here is for r to equal 0. So plugging in 0 onto the left hand side, we get minus 49 over 6t plus 125 over 3. Add the 49 over 6 onto the other side. And now we need to do 125 divided by 3. We need to times that by 6 and then divide by 49. And we get an answer for t, which is 250 over 49, which is equal to 5.1020400816. That's quite good, isn't it? You've got 02, 04, 08, 16. That's interesting. Okay, so it's going to be 5 minutes. Now we just need to work out how many seconds. So we'll take this decimal value, so we'll take away 5 from our answer, and then we'll multiply this by 60 to work out how many seconds we've got there. 6.1 seconds, so it's 5 minutes, 6 seconds. Okay, so the answer then to part C suggests a limitation of the model. The model does not consider the mint, how the mint is sucked, so it could be sucked more vigorously as it gets smaller, or generally you get bitten into as the sweets get smaller, so no biting as the sweet gets smaller, which generally people do. No biting as the sweet gets smaller. Okay, so there we are. That's the answer to question 10 then. 8 marks for that question. Let's now move on to question 11.